Checkup number 2 revisited. So I will be going through the problems, reading them, making sure we understand them, and then I will give an example of how to do a problem, but not the problem that was on your checkup. So the first problem reads, it says write 3 different factorizations. So we need to know what factorizations are, and we're going to use the number 16. So first of all, a factorization is a string of factors. So if we go down here, we say it's a string of factors. What does that mean? Well, let's pick a number like, let's say 20. So there's different ways you can come up with the factors of a number. And the most obvious ways would be to list the factors. So we could say 1, 2, 4, 5, 10, and 20. That's one way, listing the factors, and then we have to explain what they are as factorizations, pairs of factors. So let's just write pairs of factors. Well, 20 and 1. But the direction says do not use 1 as a factor, so we can't use the 20 and the 1. So I'm just going to cross those off. So we're left with 10 and 2. So one factorization could be 10 times 2. How about 5 and 4? So 5 and 4. So we have 2 just by listing the factors. Well, that's not going to get it done because we need to have 3 factors. So what you can do is just take one that we already have. Well, I'm going to circle the ones that we know are factorizations. We have 1, we have 2. Well, let's use 10 times 2. And then let's break the 10 down into 5 times 2. These are all prime numbers. So this factorization could be written as 5 times 2 times 2. A string of factors. So do we have our 3? Yes, we have 1 factorization, 2, and 3. That's one way to solve the problem. Another way could have been, for the number 20, maybe you just did a factor tree. 20. So we could say 10 times 2. Well, there's 1. Let's do another one. 20. 5 times 4. There's another one. 20. 2 times 10. 2 times 5. I circle them because they're prime, and we would have 2 times 2 times 5. So there's another example of how to find 3. There's 1, there's 2, and there's 3 factorizations. Number 2, use the prime factorizations of 24 and 28 to find the greatest common factor. So we're going to use prime factorizations to find the greatest common factor. Let's pick 2 numbers to use to do this problem and see if this helps you figure out the greatest common factor for 24 and 28. Let's use the numbers 20 and 30. So in class we learned to use factor trees to make prime factorizations of numbers. So you take 20 and you reduce it, you keep making the numbers smaller until you only have prime numbers. And I said always circle your primes, so I'm circling my primes as I go. So 20 can be chopped up into 2 times 10. 10 still composite, we make that 2 times 5. So our first factor string that we have is 2 times 2 times 5, and those numbers come right from here. 2 times 2 times 5. Let's do the same thing to 30. 2 times 15 3 times 5. 2 times 15 and 3 times 5. So what we're left with is a string that's 2 times 3 times 5. So to do the greatest common factor, for greatest common factor, let's write our string up on this line. We need to find the common factors shared. And I'll show you how to do that. And I'm gonna circle them in red. So the common factors shared. So this string has a 2, this string has a 2. So we'll write 2 times, what else do they share? Well, this string has a 2, this one doesn't have a 2, so they don't share there. This one has a 5, and this one has a 5. So we'll circle that. 5, 5. So 2 times 5 equals 10. So 10 is the greatest common factor. Number 3, use prime factorizations of 24 and 28 to find their least common multiple. So in this problem, we're going to find the least common multiple, not factor, multiple. Let's use the same numbers in our as we did in our last example. Let's use 20 and 30. And the first thing you do to find prime factorizations is you factor them using a tree. So we say 2 times 10, 2 times 5. We're left with 2 times 2 times 5. That's our first factorization. 30. 2 times 15, 3 times 5. So we're left over here with 2 times 3 times 5. Make sure you know what these numbers stand for. 2 comes from here, it's prime. 2 comes from breaking down the 10, it's prime. And 5 is also prime. So 2 times 2 is 4. 4 times 5 is 20. There's only one prime factorization for each number. 2, 3, 5. 2 times 3 is 6. 6 times 5 is 30. Okay, so now with the prime factorization, you need to make a string of factors, the shortest string. So we want the shortest string. And it has to include all the factors. So let's do that. Let's find the ones that are common. So a 2 and a 2. So we have 2 times. We share a 5 and a 5. So we have 2 times 5. And what are we left over with? We're left with a 2 and we're left with a 3. Now the rule is we have to include all. We need to make the shortest string but include all the factors. So we have to include the 2 and the 3. So let's do that. So times 2 times 3. And then we multiply. 2 times 5 is 10. 10 times 2 is 20. 20 times 3 is 60. So our answer, our greatest common factor, is 60. Number 4, find the prime factorization of the number 300. And then write your answer using exponents. Well, we won't do 300. We'll do, let's pick a number sort of like 300. Let's do 200. So in class we said always use the factor tree, break the number down into primes, and then write it using exponents. So I'm going to show you an example so that you will be able to do 300. So 200 divided by 2 is 100. Keep breaking it down into primes. 2 times 50 is 100. 2 times 25, which is a square number, so we end up with 5 times 5. So our factorization is 2 times 2 times 2 times 5 times 5. So we have 3 2's. So we want to write it using exponents as 2 to the third power times, and we have 2 5's, 5 to the second power. So that is the prime factorization of the number 200, which is very similar to the one you have to do, which is 300. 5a, what number has this as a prime factorization? So what number has 2 to the 6th power times 5 to the 6th power? Show how you found your answer. So let's go ahead and do this. So we have to show how we're going to find our answer. Well, I'm not going to do this problem. I'm going to do one like it. So we'll say, let's just say 2 to the 3rd power times 5 to the 2nd power. So I'm going to rewrite this to show how I'm going to get my answer. So I'm going to say 2 times 2, the dot means multiply, times 2, because there's 3 2's, right? There's 2 is the base, here's the exponent, 1, 2, 3. 2 times 2 times 2 times 5 times 5. Remember those dots, sometimes I use dots, sometimes I use the times. It doesn't matter, they're both the same. I've done it so much, I particularly, most of the time I'll use the dots. So now we've got it, now we can show it. Here we go, that's us showing it. Now we just multiply to get the answer. So we would say 2 times 2 is 4, 4 times 2 is 8, 8 times 4, or 8 times 5 is 40, and then 40 times 5. So 40 times 5 is 200 would be your answer, 200. So what did we do? We gave an example of how to find the prime factorization, but our example was 2 to the 3rd power times 5 to the 2nd power, which means 2 times 2 times 2 times 5 times 5. 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40, 40 times 5 is 200. 5b, is there another number that has the prime factorization of 2 to the 6th power times 5 to the 6th power? So is there another number that has that as a prime factorization? Well, let's do an example using a different number. Let's just do 2 to the 2nd power times 3 to the 2nd power. That means 2 times 2 times 3 times 3. Well, 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. So what we're saying is that this is the factorization of 36. Is there another number that has the same factorization? Is there another one that has the same exact factorization? Well, let's factor 36 and see if we get something different. We can do 3 and 12, and then we can do 2 and 6, and that would be 2 and 3. Well, we still have 2 times 2 times 3 times 3, which is 2 to the 2nd power times 3 to the 2nd power. It doesn't matter how you factor 36, right? You can say 9 times 4, 3 times 3. You're still going to always have 2 to the 2nd power times 3 to the 2nd power. So the bottom line is, students, is that this factorization right here is only a factorization for one number. There's only one number only has one prime factorization.